Hello, dear aspirants. This is Dr. Saurabh Sir's classes, and our contact number is 9836793076, 9836793076, and our email ID is saurabhsirclasses@gmail.com. Please feel free to call and drop an email in our email ID, and we will help you by the solving your doubts and by the one-on-one sessions and the regular batches. And we are eager to tell you that we are going to launch a new batch which will help you for the NBHM TIA for GS, NET, ISI and CMI, this kind of preparations. So please feel free to contact via these contact details. Okay, so now we are going to solve a question which is appeared in our 2025 GS TIFR question. So the question is telling us that for a real valued function, f is running from the closed interval 0 1 to r, where wf is running from closed 0 1 to r, b the oscillation of f, let us call it omega f, sorry, defined by omega f of t is equals to the supremum, where our mod of x minus t is less than equals to t, and of the mod fx minus fy. So which of the following statements is correct for every f which is running from close 0 1 to r? So option A is telling us that f is continuous if and only if limit t tends to 0 plus omega f t is equals to 0. Option B, if our f is continuous, then our limit t tends to 0 plus omega ft is equals to 0, but not conversely. And option C is telling us that if our limit t tends to 0 plus omega ft is equals to 0, then f is continuous but not conversely. And option D is telling us that none of the remaining three statements is correct. So what can be done with this problem? So I think this is not very tough question or either anything. So now we are going to first understand our what is omega ft. So the function omega ft is called the modulus of continuity or oscillation function. Measures the largest difference in the values of f over intervals of length at most t. So specifically omega ft captures how much f can oscillate when points are within distance t of each other. As t tends to 0 plus, omega ft reflects how locally stable or continuous f is at small scales. So now the relationship between omega ft and continuity. So necessary condition for continuity is what? That if our f is continuous, sorry, continuous on closed 0 1, yeah, then what will happen? So our for all epsilon of or any epsilon greater than 0, there exists delta greater than 0 such that our mod of x minus y less than equals to delta implies what? Implies that our f mod of fx minus fy is less than epsilon. So thus our omega ft goes to 0 as our t tends to 0 plus, because the supremum difference of fx minus fy, mod of fx minus fy over this shrinks as t shrinks. Okay, so the sufficient condition of continuity will be what? So our limit t tends to infinity, sorry, t tends to 0 plus omega ft equals to 0. Now for any epsilon greater than 0, there exists delta greater than 0 such that t less than equals to delta implies our omega f of t less than epsilon. This implies that our mod of x minus y less than equals to t, comma, mod of fx minus fy less than epsilon, which satisfies the definition of continuity. Hence, this limit t tends to 0 plus omega ft equals to 0 implies f is continuous. Sorry, nuous. Okay. Thus, limit t tends to infinity, t tends to 0 plus omega ft equals to 0 is both a necessary and sufficient condition for continuity of f. So now we are going to evaluate the options. So our option A is telling us that f is continuous if and only if this limit t tends to 0 plus omega ft equals to 0 occurs. So this is correct statement. Okay, as is a single correct question, so we can leave it now. But we have to check why our B, C, D are false. So if B is telling us that if f is continuous, then that is true, but not conversely. The converse is indeed true. We have proved that. So that is false, and similarly our C is also false, and D to D is again false. So our correct option of this question is my A. And again, I am telling that please feel free to contact via these contact details to us. Then we can support you from for the all the mathematical background or anything. Okay. Hope you understood, guys. Thank you.